Welcome to the Impulse Spotlight, a podcast for product development professionals. In this episode, we speak with a senior engineering executive whose efforts within the automotive industry helped to develop an internal radio system that provided the building blocks for products we see today like OnStar or Amazon Alexa. Our guest's extensive career has seen him contribute to industry sectors including oil and gas, industrial goods, robotics, and AI development. In his downtime, he enjoys passing his knowledge and experience to his children, teaching his daughter new technologies, how to code, 3D printing, and anything related to AI development. Art Casasa was born in Veracruz, Mexico, where he lived until he finished his studies in mechanical and industrial engineering. At the age of 24, his quest for knowledge and expertise brought him to the United States, where he completed his graduate studies, earning an MS in manufacturing engineering, an MBA, and a Master's of Finance. He also obtained a Postgraduate Certificate in Artificial Intelligence and Machine Learning from the University of Texas at Austin, and is currently pursuing a Master's in Artificial Intelligence at Penn State University. Art, his wife Marcela, and their two children now reside in the greater Houston area. After gaining valuable operations experience within the automotive industry, Art shifted his focus to new product introductions, working with Tier 1 suppliers on product development. In this episode, we discuss Art's groundbreaking work in the automotive industry and the process that brought his radio system to life. We explore the challenges and achievements of developing this system. We discuss a different perspective of prototyping for a system instead of a product, and the importance of testing for reliability and quality. Finally, we speak on rising trends within the industry, including designing for sustainability, AI's impact on generative design, as well as the past, present, and future of 3D printing. Let's get into it. Hey, Art, welcome to the show.
Hey, Troy. Thanks for inviting me.
Sure, it's good to have you here. So
Thank you.
I always start this off by telling everybody I started Impulse 25 years ago after working for a company where basically I got my master's degree in product development. They had everything under one roof: industrial design, prototyping, design engineering, tooling, injection molding, the whole gamut. Tell us how you got into product development.
Yeah, sure. Thought about the question quite a bit, and I think I'm just gonna get you to the very start. The very start was in automotive. I was working in operations actually in a manufacturing plant, and I was in charge of introducing new products into the plant. So I was working in quality operations, making sure we had the right speed. And at some point in time, I actually requested my company to give me the opportunity to look at the whole new product development cycle. And that's when I moved from operations into the whole cycle, developing automotive products in Detroit.
Okay, interesting. And so I know it's pretty broad, but tell us about a little bit of your history developing products.
Sure. We can start with the automotive industry. So one of the main products that I had, and it was a system. We were developing radios, speakers, amplifiers, harnesses, and the whole telematics package, which back then was the whole interaction with the automotive system. So
Okay.
if you see it from a new product development perspective, you have the system interaction from mechanical engineering, electrical engineering, software engineering, interacting with GM, Chrysler, Toyota, the OEM suppliers, as well as interacting with other suppliers where you were going to mount your parts or you needed power. So it was the whole system by just developing one package.
Interesting. So tell us a little bit more about it. Like what were some of the key features or innovations or things that we wouldn't see if we saw it, in the wild, so to speak?
So some of the key innovations for the process development, and this was an eye-opener for me at the time, which was having every single supplier in one room with the whole CAD data displayed, where you can just mount your parts, of course, before the meeting, and then you can discuss with suppliers on interferences with their parts, power requirements, all of that. So the whole process was mapped for us, right? Now, as far as features for the radios and the speakers, we were actually one of the main acoustic suppliers in the world. developing systems for, like I said, GM, Toyota, Chrysler. And now back then, some of the key features that you wouldn't see at the time was different touch screens that interacted directly with the customer. You didn't have that at the time, and some other, and this was just new to the world sort of things of discussing or talking to the actual radio to make things right. So what we know now as Alexa and all these products that are coming in for natural language processing.
Interesting. So were there any, I mean, you mentioned a couple, the touchscreen and all that, but were there any other novel technologies or materials or methodologies you guys discovered while developing the product?
So the most difficult integrations at that time were with actually modules like Sirius module, the XM modules, antennas, and making sure that you had the telematics package completely installed and being able to remotely call for services, right? When you crash your car, all of that. So all that was new at the time. So those were new technologies that were evolving, right? Of course, the other main thing that and this is a trend in automotive, you always have to reduce costs, so, and reduce weight. So we had to, this was a never-ending curve of changing materials, looking for new ways of modifying your cost. So we discovered many things, right? So we started using new aluminum alloys for the speakers, for the radios, for every single part that goes inside any metallic part, as well as reducing the footprint of the PCBs. So those were 2-3 years of development where we were able to reduce 30 to 40% of weight as well as cost in the first generation.
Interesting. So I didn't realize that. I assume you're talking about OnStar for the emergency call. That's all part of the radio system.
Right. It has to be connected to your radio, right? It's just the whole telematics package because it goes through your speakers, through the amplifier. Yeah. So you need to make sure that there's no failures when things happen, right? So, which was a very interesting experience, being in the OnStar call center, listening to calls, going there and actually looking at how the products are used and how you can improve them. So yeah, everything needs to be connected. So no point of failure in that one.
Yeah. You mentioned reducing the PCB size. Is the PCB like right there in the dash behind the display, or is it somewhere else in the car?
It is right there, right? And it could be one PCB, it could be stacked PCBs. So we always worried about costing. We always worried about the footprint, power requirements. So it's a never-ending curve, right? And I can just as an example, when we started the first, let's say the radio was $100, which it wasn't, right? But when we finished the cycle of cost development or cost out, after 5-6 years, you could see a cost down of maybe from 100% to 65% of the original cost, which was tremendous, right?
Sure. Interesting. So I'm getting a little bit off track here. Sorry, but it just popped in my head. With the PCBs, do you guys have to build in some kind of dampening to deal with vibration and things with that, or are they just robustly built? How does that handle?
So in the automotive industry, you have a very robust reliability testing, right? So you go through vibration. You have certain Gs that you have to pass. You also go through dust, cold chambers, hot chambers, all of those things, right? Whatever the radio is going to see or whatever your components will see. So we had to make sure that every single component passed. I forgot the amount of Gs that they needed to withstand, but yeah, it was built into the PCBs, right? Into that radio. Actually, the most difficult part, you don't see these radios anymore, but the most difficult part was how to dampen vibrations in CD changers. So when we had DVD or CD changers, there were so many mechanical parts that dampening every single vibration to avoid any mechanism problems was tremendous.
Yeah, I didn't think about that, but yeah, I'm sure that was an engineering feat in and of itself.
The whole mechanism was very, very, very complicated.
Yeah. So we've helped literally design thousands of products, and every one of those journeys is different. Can you kind of walk us through the journey of developing this system and like what the steps involved were?
Yeah, so in general, right, the steps are requirements, and then I can go into the more into the details, but it was requirements, first prototypes, prototypes at the plant, and then starting running those prototypes at scale, and then doing the launch globally. So this is very detailed in the automotive industry, where you have certain quantities that go for prototyping A, prototyping B, and it depends on the customer. But probably the most interesting part, if you work in the automotive, is that the requirements, once they are set and they try to front load everything, they actually respect very much the original requirements. Changes are calculated throughout the cycle, as opposed to any other industry. I've been in several industries where the requirements keep changing almost until you start going into production. But like I said, important parts in that was making sure your prototypes were up to specified requirements. And an interesting part of the process was, and this is not something that every system does, is going and actually running your production line and making sure that the first parts that you have out of your production line are qualified to the same standards that your engineers are qualifying for. So you have your engineers, lab settings, and then your production, which is out of the production line. You have to compare the reliability results, which you always found out things happening, issues, complications. So that was very interesting in the automotive.
Yeah, yeah. What was the timeline like to develop the system?
Typically, is if you're just doing a changeover, is about 16 months. But if you go for a whole new system where you have a brand new vehicle, it's about 3 years.
Oh, wow.
So it depends, right? If you're putting whole new technology into that, it's about 3 years and a half.
Is the only reason they would change the system is because they're adding or updating technology, so they have to build a new system to adapt?
Yeah, correct. So as the radios started moving in technology, you started adding Bluetooth, you started adding all these USB connections, and then Wi-Fi. So those are only modules that you just keep adding to the radio. But now, if you're talking about a whole new technology, like we have, or we're going to start seeing now, of talking to your radio for giving orders, then that would be um, a brand new cycle that will take years.
Yeah. And is that just a PCB update, or do you have to update the entire system?
The whole
all the way
package,
to
right?
the
So if the component doesn't fit, you have to work on the whole package around.
Yeah. And so if you weren't working for a specific auto company, right? You were more of an OEM.
I was a tier 1 supplier, which we were working with all OEMs, mostly all of them.
Okay. So when you develop a radio system, you're not developing an entire new system for, let's say you did one for GM, you're not doing a whole new system for Ford, right? Do you just,
correct.
Are they identical, or do you change out buttons, or, make it look a little different, or?
So there's all this intellectual property that each one of them have. Now, the common components, which are the Wi-Fi modules, Bluetooth module, every single module is just something that they shared in between. But the packaging itself, is completely designed as per the different suppliers. Now, the other very interesting thing that might not be known is that every single radio and speakers, they are tuned per vehicle, and that tuning it's sort of the secret sauce that each supplier has. So
Okay.
you go into a Cadillac, it has certain tuning, right? It's a certain sound, as opposed
Hmm.
to you go into a pickup truck, it's going to have another sound. So
Yeah.
that's more of the after we finish the development. Now let's go and test how does this sound with customers.
Very
So
interesting.
so yeah, and there's actually a process that where they qualify you as the quality of sound. Very
Interesting.
subjective though, but
Sure.
interesting.
I can imagine. Yeah. So did you just supply like bezels and buttons and everything, or were you just plugging into, kind of their bezel design, or their what the consumer sees?
So we were plugging into the dashboard. So
Okay.
when we were working with the other suppliers, we would bring our package or our CAD package to the or the envelope to the meetings and
Hmm.
make sure that the speakers, the harness, nothing was interfering.
Okay.
Many times we had requests to move the position of screws, the position or the actual envelope that we had, because we
Hmm.
were interfering with the air conditioning, or we might be interfering with uh, parts that were going to be heated, and then we would cause a safety issue. So that interaction with suppliers, that was very interesting too, because you had certain radius that you had to be aware of.
Sure. That's interesting. Tell us a little bit about the team involved. Like how many people were involved in the development
Oh,
and what were their roles?
sure. I mean, this is the whole product development cycle. So we have engineers working on the requirements. We have manufacturing, operations per se, which included supply chain quality. We had, of course, all the design engineering, and that was mechanical, electrical, software. We also had all the marketing people working on the communications. Once we were out, we would help on marketing the product with the actual OEM. So it was the whole cycle, every single part. Of course, sales right from the beginning. So we have engineering, sales, manufacturing, you name it. So every single part of the company was involved in that. And the reason is we were product development companies that happened to do manufacturing for for the OEM companies.
Mhm. Interesting. What were some of the key milestones and achievements along the line that you reached?
So when you go into product development, the milestones are very well defined, and it depends on the OEM. But it's reaching prototypes. Some of them they call them electrical mules. Then first parts in their vehicles. They usually have one, two, sometimes three prototype vehicles where you need to test your parts.
Okay.
So that was sort of the milestones before going into launch. The other um, key milestones was going through their audits as far as quantity. So we would have every single OEM visiting our plants in China, Mexico, all over the world, just to make sure that we had the quality and the quantity that they require. So that was the biggest milestone was that. And then after that, sort of the last milestone was to pass their all the set of reliability testing that we had to do. Once we have passed that set of reliability and it was comparable to the initial testing, then you
Mhm.
would say, okay, I completed the program. Now you sort of handed that out to operations for scaling up.
Interesting. You were talking about the quantity. Surely you didn't have to pre-build every radio system. Did they just like look at your throughput and they understood, okay, you can make X number per day and we have this many days, and that's how they knew you were going to reach the quantity? How was that validated?
It depended on the OEM, but for example, a normal, I'd say, speakers, right? For example, a normal speaker production is 6,000 to 7,000 speakers per shift in a manufacturing company.
Hmm.
You would have to at least produce half a shift of parts to make sure that they reached the quantity and quality levels that they were requiring. Same for radios. So it wasn't cheap. It wasn't like, okay, I'm going to build 5 radios. Please accept my radios. No, that was a whole, they call it run at rate. So you have to run and you had to make sure that everything went okay, right? Because one mistake, it will show up in the end results, and you wouldn't be approved to supply.
Right. And so they're just validating your abilities to deliver, ultimately.
Correct. Right.
Yeah.
And it's very specific to the automotive. You have to be running at rate, making sure that, yes, there's no problems.
Yeah, interesting. So with all the products we've helped design, there's always some kind of challenge that comes up. What was the biggest challenge that you and your team faced developing the system?
Most of the challenges that we had were, I mean, you just mentioned a few of them were vibration testing. The other ones were passing the heat cold cycles, especially for some, when you had new components, you didn't really know how they were going to behave at very high temperatures or very low temperatures. Mm-hmm. So the reliability part, and in some instances, we also needed to prove the whole supply chain was able to produce parts. In other words, it wasn't only our production line. We need to certify and sometimes bring the customer with us for critical parts. So that was a challenge, right? Traveling around the world and making sure that we had all the parts. So those were never-ending challenges, right? Reliability testing. The design part, of course, it has their own challenges. I mean, there's always going to be problems happening, especially in the first prototypes that we need to resolve.
Yeah. You've mentioned prototypes several times, and in the world I live in, we'll build 3D printed prototypes all the time. Yeah. I'm guessing you're not talking about that kind of prototype when it comes to getting this thing up to production. Walk us through that process a little bit. Like, how does it differ from just 3D printing, and then how does it differ from like what's going to be the production result?
So for those quantities, as you know, right, 3D printing, you can do just a few parts. When you're talking thousands to prove out your product, you have to go into soft tooling. So we would have a soft tooling for a while until we had to produce certain quantities. And then we would start cutting what they call hard tooling. So the process was, hey, go through your whole validation with soft tooling. If everything is okay, then start cutting for hard tooling. It's actually an expensive process to validate parts, but that was what was required when you're producing those quantities. And I think the most important part is where you talk that your parts per million at the plant, whatever you were going to ship, had to be single-digit ppms. So to achieve that, the amount of testing and assurance that you have to do has to be really outstanding to go into single ppms, right, at the plants. So
explain that to me a little bit more, because I don't understand it. You're saying your rate could only be so much, or what is the
so most of the requirements to be an automotive supplier, I don't know if they all of them, but for most of the US suppliers, you have to be single ppm, which is just you're talking if you're supplying 1 million parts, and we were supplying maybe 100,000 parts, 200,000 parts, you're talking about 5 defective parts found at the plant. And single digit, you have to be between 1 and 9. So 10 was already double digit. So you will be called out for a meeting of why your process wasn't in control. Now, in order to achieve that quality, there's this whole background of testing that you have to do, and background of, like I mentioned, run at rate to achieve those levels. So that's the relationship.
Okay. And do you have to achieve those levels from a prototype standpoint and then do it again for production, or is it only production?
All the time.
Wow.
So if you saw like the first run rate, which came from usually soft tooling. If you were not achieving those quality levels, you had to explain how were you going to achieve those quality levels. And production was known that you had to be single digit.
Yeah.
And
Interesting.
the reason for that is you don't get more business in 2-3 years if you cannot achieve that.
Right. Interesting. So if you could go back in time and change one thing about developing the system, what would it be?
I wish there were more simulation tools
Mm.
when we started developing those systems as we have right now, where you can model more of the how metals are gonna behave, how stress is gonna affect all those metals, how stress is gonna affect all your elastomers, all your plastics. That would have been great because you would just shrink your new product development cycle. Now we have those tools. Of course, they are not perfect, but much elaborated than when I started in automotive.
Yeah. Yeah. Interesting. Yeah. Those tools are the prices are dramatically dropping for the tools, and the tools are getting better and better. And yeah, I can't imagine how much it would have made your life easier to have
Yeah,
one.
absolutely. It was, yeah, it's a tremendous help right now.
Yeah.
Everything new that's coming out is unbelievable.
Yeah. So shifting gears just a little bit as we start to wrap up, what are
Sure.
some of the trends that you see emerging in product development?
That's a very, very good question. There's some main trends that I'm seeing is, of course, sustainability. And now you're seeing most companies making sure that their products are sustainable for generations to come. So that wasn't something that was taken into account 20 years ago, right? It was there, but it wasn't as much as right now. But probably the biggest trend that I see is the use of artificial intelligence.
Sure.
That's gonna significantly change the game in product development. Like we mentioned, right? You have all these tools. The tools will keep getting better, but you're gonna get generative AI now for what they call text to part, text to code,
Mm-hmm.
where your CNC code is going to be diminished, right? So the amount of time that you take to do that is going to be diminished. The amount of time that you take to prototype is going to be diminished. All of those things will happen. Plus, if you add 3D printing on all the additive designs that you have right now,
Mm-hmm.
maybe you're going to start seeing designs, more organic designs, where you don't have all of these right angles with stresses. You might still you might see some of those in almost any industry. If you can produce a part that shows less stress or less points of failure than right angle parts or machine parts, it will certainly change how we see parts in the next 5 to 10 years. I don't think it's going to be more than that.
Sure.
So I would say those
No,
are the three main ones.
yeah, I've already seen, at least from a low volume standpoint, a lot of clients using 3D printers for production. And
Yeah.
obviously you can do a lot of things that you can't do in an injection mold. So yeah, it's going to be really interesting to see how all of that plays out.
Yeah, absolutely. I do quite a bit of 3D printing with my daughter,
Mm-hmm.
and just simple 3D printing is just unbelievable. Less than $1,000 3D printer. What you can print nowadays is just
Yeah,
mind blowing to what we do. So
it
very
is.
interesting.
Yeah. Like me, I'm sure you kind of grew up around when prototyping was new. SLA machines were new, and
Mm-hmm.
they were first one I was around. I think the company I mentioned that I work for, they had one. I think they bought it for 1.5 million.
Wow. Yeah.
And now you can get a desktop printer for $500. That's
Yeah.
almost as good as that one was.
Yeah. 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 It's just unbelievable, right? And once you start, the other thing, right? Once you start, or the metal printing is up to speed, and the characteristics of that metal are, and I think they're comparable now with regular extrusion machines and all of that.
Mm.
That's going to be a game changer. If you get
Oh
the
yeah.
speed, and you get the right metals in there, it's just gonna revolutionize the way we do manufacturing.
Oh yeah,
So
yeah.
no, I think
I was just reading the other day. I think it's been around for a while, but I'm just slow on picking up on it. I think it's Haas, the CNC machines. They have a metal 3D printer that prints straight into the machine, and then they'll come in and machine off, the critical areas, and so almost no scrap, no waste. Yeah, it's pretty amazing.
Yeah, and I think the last example, I'm not sure. I think it was SpaceX. They built one of their rockets with a 3D printed, with a circular 3D printer. So I mean, of course, it's a long process, but if those metals can withstand that stress,
Yeah.
there's no. I mean, the new horizon was the horizon was here. Now the new horizon is here, right?
Sure.
Is so many things that you can do nowadays.
Yeah, yeah. So reflecting on all of the challenges and successes that you've encountered developing products, what words of wisdom would you share with somebody looking to make a significant impact in the product development world?
So I guess one of the first things, and this is more on the human aspect of new product development, is making sure that you communicate properly throughout the whole chain of new product development. If you're developing requirements, everyone needs to be aware of what you're doing, because if they're not, you will regret it at some point. If you start designing your products without the voice of manufacturing or without the voice of maintenance, something will happen. So you have to be aware that it's not only engineering, it's a whole chain that needs to be fed. That's one. And the other one is look at the new technologies that are coming out. Don't try to reinvent the wheel in terms of technologies. If they're out there, use them. If you need to invest in new technology, it's fine. But for starting production right away, look at what's out there. Look at 3D printing, look at AI. What can you use that is proven and use it, right? So we're in a change time. So might as well just jump in the curve and get in the wave with that.
Yeah, yeah, very good. So this has been really good. Before we finish up, though, is there anything else you want to mention in regards to developing the radio system that you talked about, or product development in general?
Well, I guess I've been in product development for the last 25 years in many forms, in engineering, in manufacturing, in program management. New product development, new technology development is probably one of the most, for an engineer, right, is one of the most fulfilling things that you can do. See something from nothing and then coming out with something that is in the market, or maybe something that is saving lives, or maybe something that is helping others. I think it's a great career to get into. So whether you're in manufacturing, in engineering, mechanical, it doesn't really matter. If you can actually use what you know to affect the world that we live in right now, it'd be amazing, right?
Yeah.
So that's my words of wisdom for anyone in new product development.
No, I totally agree. So yeah, normally at this point I would ask where we could find the product, but I don't think we can find it online or anything like that anymore. So maybe it's in my old GMC or something.
Probably, yeah.
Awesome. This has been really fun. I appreciate you doing this, Art.
Thanks so much. Thanks for inviting me.
To learn more about Impulse and how we might be able to help you, visit impulseproductdevelopment.com.